Okay, so let's get started with session 1 of the online mentorship program. Yeah, just an outline of the presentation. We're going to go through the objectives of the program, the schedule, which is sort of very tentative at the moment. This is just for the first 3 or 4 sessions. And a quick introduction to Alicanto Groundwater, what we do and how we were founded, etc. And then to the meat of the session 1, we'll go through what a hydrogeologist does, how to design your project scope of work, and then we'll do like a little question and answer session.
Okay. Cool.
Okay, so the reason that I wanted to do this online mentorship is just to give an entry level and a junior sort of professional an opportunity to, sorry, I just want to see, just an opportunity to get a bit of exposure in the industry and what we do, and like a little bit of sort of guidance, like you would if you did an internship. So instead of having an internship, which we can't really do at the moment because of the COVID and because of the economy being the way it is, I thought we can do an online thing just to give that little bit of basic training, and so when you do eventually get a job, you've got that foundation. Okay, and in terms of schedule, we're going to have this introductory session today with what a hydrogeologist does, types of projects, and then designing a scope of work. The second session, which I'm planning for the 16th of July, which is next week, Thursday, we'll go through the groundwater resource development process, which is includes your desktop review, what to look for there, how to look for it, your geophysical surveys, the methods, the design and the interpretation, then the borehole installation and aquifer testing programs, groundwater sampling and chemistry, your interpretations and actually how to do it, and then pump selection. Session 3 on the 23rd of July, go through the scope of work design, what to look for in your groundwater characterization, and then how to develop your conceptual model. And session 4 in August, the reason that it's going to be a bit delayed is just because I'm going to be out of the office probably at the end of July. But we'll keep that open. We'll change that as we go along. In that session, I want to discuss the types of models, the applications for models, then how to select the model, when to do analytical, when to do numerical, and then your modeling process and how to compile a modeling report.
Okay.
Give me a second, guys. I just want to see if anybody else has tried to join. I don't see anybody else. Yeah, okay. So I think it's just us. So just an introduction to Alicanto. We were founded in 2018, so we're a young company still. We have a vision of providing high quality, cost-effective groundwater solutions for South Africa and the African stakeholders and industries. We believe that the management and development of groundwater resources is critical in providing water security for both current and future generations and plays a key role in the economic success of projects. We use our experience, partnerships, and passion for groundwater to assist our clients in every phase of the project lifecycle, from their initial designs up to the feasibility and final commissioning and closure phases of the project. Each of our projects, and this is something that I think we're quite unique with, is tailored to our clients' specific needs and requirements. This allows us to support clients from your domestic small scale up to your commercial and mining sector large scale projects. And we focus on the sustainability triangle, or pyramid, if you want to call it that, in our guiding values. So we considered the people and the society around the project, the economy, economic benefits of the project, and then the environment in everything that we do. Our key services are groundwater resource development, mining hydrogeology, water management solutions, and groundwater numerical modeling. My key experience has been in the mining industry across Africa, which you can see there in the blue. That's all of the countries that I've worked in. And then with our logo, those are the countries that Alicanto has worked in so far. And I've been modeling using both FeeFlow and ModFlow for the last 6-7 years, on mining projects predominantly, with a few groundwater resource development projects as well. The keyboard doesn't work. What does a hydrogeologist do exactly? This helps us to determine where we're going and what we need to focus on. Hydrogeology, you also call it geohydrology or groundwater hydrology. The difference, everybody's got a different definition of why it's different, but in my opinion, there's not much of a difference. Hydrogeology is the study of groundwater, which deals with the underground components of the hydrological cycle. Which way is it going now? And then a hydrogeologist studies the ways that groundwater, which is the hydro component, moves through the rock and soil of the earth, which is the geology component of hydrogeology, and applies scientific and legal knowledge to develop both develop and protect groundwater resources. And we need to work closely with the community members, the borehole owners, mining and industry representatives, and other scientists, especially the surface water and GIS scientists, in our attempts to solve some of the big questions facing society today, such as sustainable water supply, and the water energy food nexus, and environmental protection and climate change resilience for water supply in societies. The typical things that we do, that includes your design, execution, and interpretation of geophysical surveys, where you aim to site hydrogeological drilling targets for the development of groundwater supply boreholes. Then the actual design, construction of groundwater supply boreholes, design of aquifer testing programs, and interpretation of these results to get the sustainable yield and abstraction plans. Understanding the interaction between groundwater, geology, surface water, and climate environments at a site to develop a conceptual model, such as that picture there. You can see all the different geology with the structures, recharge, groundwater flow, all of those things. This we'll go through in a bit more detail on the modeling section. Then developing our numerical models or groundwater models to simulate the potential impacts of abstraction and or contamination of groundwater at a site. And this is to sort of simulate it before it happens and before you get your costs, so that you can develop your management and mitigation measures to limit the effect of these impacts. And design with the models or with your aquifer testing information, we can design dewatering strategies and plans at mining and construction sites to ensure safe working conditions. And then we investigate the quality of groundwater resources to make sure it's safe and sustainable for the intended purpose. Okay, so is there any questions or comments or anything up till now?
No.
Am I going too fast or too slow, or?
No, it's fine.
Okay. Neil, Johan, Patrick?
Yeah, it's fine.
Okay. Yeah, look, this is my first time doing a presentation as well, so yeah, I just want to get feedback from you guys. Feel free. Okay. So now, when we design our project scope of work. This is one of the most sensitive stages of any project, or it can be. This is where you start trying to figure out what your client is asking for, how much money they, sort of you telling them that they need to spend upwards of R1 million potentially on a project that they didn't think would be that expensive. And I'm sure anybody that's dealt with a client before, this is where the wheels can come off. So you need to make sure your scope of work not only meets their time and budget requirements, but you also need to be scientifically accurate and compliant with the regulations and legislative requirements for the project. You can't, or you shouldn't do projects just to fit the client's requirements. You have to make sure that you're scientifically and legally compliant as well. At the end of the day, you're a scientist, so you have a scientific method to follow. You have scientific integrity to uphold. So always remember that. Rather lose the job if you are going to sort of compromise your integrity. Because unfortunately, you do get clients that will push you. Okay, so then when you design, some of the key factors that will influence the scope of work selection process will be, what is the study intended for? Is it input into a water use license? Is it a EIA? Is it a standalone water supply development report, dewatering report? What is it for? What is the intention? What is the time frame? Because even if it is an EIA report, if the client's given you a week to do it, it's not going to be an EIA report. Whether it doesn't matter how much money they throw at it, or that it can't be. So your time frame also plays a role in what you can realistically do and do properly. What is the required confidence in your study's results? This also comes back to what the study is for. If you've got a feasibility study where you're going to invest $300 million into a mining operation, you can't have a study results of 40-50% confidence. You need to go up to a 90-95% confidence if you can. Whereas if it's just a domestic borehole, and the guy is a multi-billionaire, 50,000 Rand is not that much to him, you can do a high-level study for him. And then what phase is the project in within the project life cycle? The project life cycle starts off at a design phase or an idea stage, where you're putting all of your things together. So groundwater might be a key component of it. Then you go into exploration, operational, at mining and construction sites. This is where groundwater supply and monitoring would become quite important. So each phase of the life of the project has different groundwater requirements and needs that you might have to take into consideration. And then what data is available for the site? Have they got monitoring data? Have they got previous reports available for you? Or are you building a baseline completely from scratch? That'll influence, obviously, your scope of work. If you have to collect every single piece of information, obviously it's going to take longer, it's going to cost more, it's going to be a bit more difficult to execute the project. Then this graph is something you have to keep in the back of your head all the time, where you've got increasing confidence results usually in an increase in the cost and time of a project. And we typically, as consultants, we are selling our time. So cost and time go hand in hand. And you'll go up to 40-50% for your low-level projects, developing a borehole for domestic use, those kind of things. And then 80-90% is where you're looking at your pre-feasibility, bankable feasibility studies. And 60-80% is everything else in between, your water use licenses, your EIAs. Obviously, more confidence is better, but sometimes it's just not realistic to get 80-90% with a limited budget and time frame. Okay, so is everybody with me so far?
Yes.
Yes.
Okay. So now typically I like to do my projects in a phased approach, where you've got your phase one, which is your data collection, the desktop reviews, and then your analysis of the desktop data, the field investigation, then the aquifer characterization and modeling, impact assessment, and then your report compilation phase. By putting it into a phased approach, at the end of each phase, you can sit down with a client and say to them, okay, we have less potential based on the desktop review for groundwater resource development. Therefore, I recommend we either stop the whole process to save money, or we redesign and we reevaluate the field component or the modeling component. So at least if you have to stop the project, you stop it at, you've sort of ring-fenced your phase one costs and your phase one deliverables away from the rest of the contract and away from the rest of the project. Each of the phases interlink with one another. But by doing it and splitting it and discussing each phase individually, you can save your client a lot of money, and you can also avoid running into a situation where you do geophysics and you do drilling, even though your desktop review said there's very limited groundwater potential at the site. Or there is dolomites, there's dolomitic caverns, and you lose drill rigs and you lose equipment down the holes. That's why I prefer personally to do a phased approach. And then I'm just going to stay on this slide for a bit, just to discuss each of the phases and sort of the deliverables that you typically have in them. In your phase one, you typically have your project initiation meeting, the site visit, the desktop review, hydrocensus, and then your gap analysis or sort of pre-feasibility report, where you say, okay, this is what additional work we need, this is what needs to be added to the remaining phases, this is what needs to be taken out of the remaining phases. You do that in your phase one. Phase two, you do your intrusive tasks, which is your geophysics, your drilling, your pump testing, water sampling, geochemical sampling, anything that you need to be on site and you need to be getting in people's ways, that goes into your field investigation. That's why we call it intrusive, because you have to go bug a mine manager, you have to go bug one of the sort of process managers at the site. In aquifer characterization, you start developing your conceptual model of the site. How does it work? How does it interact with the rest of the environment? What kind of aquifers are there? How many hydrogeological units are there? That helps you to design your model, whether it's an analytical or a numerical model. You do that in phase three. Phase four, your impact assessment, which is where you take your environment and your proposed activities and you put them together, see what the impact of your mining or your abstraction or your dumping is going to be on the environment. That helps you to design your groundwater management plan for the site, which helps you to mitigate and manage these impacts that you've identified. And phase five is you compile your technical report. And that obviously summarizes all of your results, and you go forward from there. Pretty straightforward, isn't it? Okay, so designing your scope of work for a water supply project, which is something that a lot of people were interested in before the lockdown. The sort of need, or at least in my company, has gone down. People aren't drilling private boreholes that much anymore. But this kind of thing, it's bread and butter for a lot of consulting firms. So depending on the volume of water that you need at the site and can take at the site, you're going to have different licensing requirements. So you're going to have a Schedule 1, which covers your sort of domestic use. There is an article on our website and on our LinkedIn page just about the different types of water use and how they're licensing. Schedule 1 covers your sort of basic domestic use where it's not a lot of water that you're taking. Existing lawful use is where it was licensed before 1998 when the National Water Act came in. General authorization, each catchment will have its own sort of, what can you call it? It's like a freebie almost. You can abstract up to this amount on your property without doing a full water use license and without negatively impacting this quaternary catchment. And then above that, you would need a water use license. And there are, I think it goes up to K or L, the Section 21 water use license or water uses for your water use license. So there's a lot of different things that you need to apply for in your water use license. And where you need to develop your borehole, you do it according to the Science 10299 requirements, which we'll go through here in this presentation quickly. And when you need to do a water use license, in addition to developing the resource by science standards, you go on government or GNR 267 of March 2017. That lists all of your requirements for a water use license study and report. It's got a very nice sort of list of details of what we need to include in our hydrogeological reports, which I like to sort of translate. I'll show you an example just now of how I say this is what's in 267 and this is what I've actually done. It sort of defends your report to Water Affairs before they start saying, no, you're missing something. So we'll go through that. In terms of your Science 10299, you've got 9 components of the standard. The first one is the location and siting of your boreholes. You get your desktop review where you can identify any sort of jump out exclusion zones. Is it a protected area? Is it within an estuary? Is it, right next to a huge water supply project for the town? Can you actually do groundwater resource development there? Then you look at your aquifers and you say, is it a productive aquifer? If I'm looking for a yield of 300 liters a second and my average yield of boreholes in the catchment is 0.5, it's not feasible to drill 600 boreholes, just to supply one project. Then you determine if your geophysics is possible. You do a survey, which we'll talk about in the next session, how to choose your surveys and that. And where geophysics is not possible is where you've got your power lines, you've got your underground infrastructure, your underground water pipes and your underground electric cables, etc. Those interfere with most of your geophysical methods that we use. We typically use magnetics, electromagnetics, and resistivity. And they're quite sensitive to the electrical noise that you'll get in residential and industrial areas. So there you would go and site your borehole based on the geology, based on site observations that you make, and then sort of do a professional estimate of where water would be found. Okay, number 2 is the part 2 of the standard is the design, construction, and drilling of boreholes. So you select your drilling method. Typically, we use in South Africa, because we've got fractured rock aquifers, we use straight air percussion. But in areas of sand or unstable, unconsolidated formation, like maybe the Northern Cape or in your badly dewatered dolomitic zones, you would consider an Odex or Symmetrix drilling, mud rotary drilling. All of those kind of things you'll consider per project. And during drilling supervision, what we need to do as a hydrogeologist is we need to record our daily site diaries. Or at Alicanto, this is what we do anyway. You've got a daily site diary which records how many meters were drilled, what diameter they were drilled at, the casing that was installed, the diameter, the type of casing, all of these things that relate back to the invoice that the driller is going to submit at the end of the project. Yeah, because unfortunately a borehole is just a hole in the ground. You can't see down it. So if a driller says he drilled 100 meters, there's no way for you to prove that he didn't, unless you've been watching. And that's what we do the supervision for in part. And the other part is to do the logging, which is where we record the geology, the water strikes, all of those sort of physical properties of the borehole. And we use that to design the borehole, where the slotted casing goes, where the solid casing goes for your construction design. Part 3, the pump test. The type and the duration of the pump test we choose based on the intended borehole use, which we'll see in the next slide. That ranges between a 12-hour test up to a 720-hour test, which I've personally never done. But for power stations, that's what they recommend. So once you've done the pump test, you're going to do the pump test data analysis, which we'll go through in the next session, to determine either your transmissivity, storage values, or your aquifer parameters, and then also your sustainable yield if it is a supply borehole. So this is the table that is in SANS 10299. You can see from a livestock or domestic use borehole, they say you can just do an extended step test for 6 hours, which is sort of like I'm sure you guys would have heard of this in varsity maybe. They call it like a farmer's pump test, where, the farmers, what they would do is they'll get the pump and then they'll choke the pump to hold the water level at a certain level. And then that's the rate that they'll pump it in. So that's sort of my opinion of an extended step test. Same for a hand pump. You can see where there's the low cost, you do the shorter duration, a 24-hour pump test, constant discharge rate test, and a step test. So where you got this combination, you'll use the step test to determine the constant discharge rate, abstraction rate. So typically you'll start the step 1 at 30% of the recorded blow yield of the borehole, and then you'll increase it by 10 to 15% based on your drawdown observations. So step 1 will be 30% of blow yield, step 2 might be 40%, step 3 50%, step 4 100% or 110%, depending on the response that you're getting from the borehole. And then you'll use that to determine the rate that you pump at for 24, 48, 72 hours. And you can see the last two here, the constant discharge rates are huge, huge amounts, 100 hours, 48 to 720 hours. That is where if the borehole doesn't work, there's a huge financial implication. If you have to shut down a factory or a power station because of water supply issues, that's a huge cost implication. So it increases your confidence in the results. Is everybody with so far?
Yes.
Yes.
Okay. Any questions so far?
No.
Nothing. Okay, we'll carry on. So part 5 talks about the selection, commissioning of pump equipment for your boreholes. Personally, I don't get involved with this. I've got a supplier that does my my work for me, or my design for me, because they've got a lot more experience than I do, and they know what the pumps are doing and those kind of things. Just what you have to be aware of is if you go for a solar pump, they are typically, in my experience, about 4 to 5 times the cost of a conventional electric motor. I don't know why, but for a small pump, a conventional quote we got, I think, was 16,000, and then the one with a solar motor was about 80,000. So I'm not sure. Just be aware of it. Don't sell solar as an equal cost to the client. It does cost a lot of money. So just investigate it before you do that. And then you do in part 6, it's the installation and commissioning of your equipment. Usually you have to get an electrician to come out and commission the sort of works there, the power supply that connects to your DB boards, etc. And part 7 of the standard deals with something that's becoming more and more relevant in sort of Cape Town and the Western Cape, is the rehabilitation of boreholes. That's where you've had a borehole sitting dormant for 10, 15 years. So it's got a bit of biofouling in it. The casing might be rusted. So then you go in and you rehabilitate it. So that could involve your disinfection of the borehole, your pump equipment removal and replacement, or re-drilling or recasing of a borehole, depending on how bad it is or what's needed. Part 8, we deal with the management of your boreholes. Now, groundwater management is something that I saw people were asking for in this mentorship program, and it is something that we're going to focus on. So with that, you need to manage your abstraction rates, your abstraction schedules, the water level monitoring and the water quality monitoring frequencies and your procedures. How do you sample, when do you sample, what do you sample for? And then you have to have management and mitigation measures. What happens if I dewater this aquifer? What is my response plan? What happens if I contaminate the groundwater? What is my response plan? All of those kind of things. So we'll discuss that in I think it's the 3rd session. Developing your management plans. And in your groundwater management plan, what we typically try to include is a description of the management philosophy for the site, which you can translate into your company policy. Like on a mining site, for example, they would have an environmental management policy and plan. You need to make sure that your water management aligns with that. Because if someone has to go 1,000,000 miles out of their way to go do something that you've proposed, it's most likely not going to happen. We're all people, and our clients are people as well. So if they don't buy into it and it's not easy enough to do, then it's not going to get done. Then you've wasted your time, that you've wasted their time in writing this thing. So always remember that it has to actually be doable. Then you have to include your management strategies for groundwater, which includes your abstraction schedules, your water saving measures that you can implement at site. For example, water saving, something that I've been looking at quite a lot is grey water reclamation, where you can take your grey water and divert that into irrigation or dust suppression on a mine site, all those kind of things, just to save and reduce your input water requirements. Performance objectives, you have to associate those with your management strategies, and you have to assign them to a person or a department. Because again, if it's that saying, somebody should have done it, anybody could have done it, but nobody did it. Until you say this is your problem, nobody's going to really take initiative. Then you have to do a detailed analysis of your available management options and then your motivation for the implementation. You need to tell the client why they need to do this, how they're going to do it, how it's going to help them. And that feeds into the next point, where you have to do a short, medium, and long-term action plan for the implementation. You can't just do a blanket implementation of this management plan on a site. It needs to be done in baby steps. People need to have time to adapt to it, sort of build their routines around it so that it happens. And then finally, you need to have control and monitoring measures to be implemented at the site, which will feed into the site's quality management plans or health and safety plans, whichever one sort of dominates the narrative of that site. Okay, and then the last part of the Science 10299 is the decommissioning of water boreholes. This is something I've personally never been involved in, but this includes your temporary decommissioning, where you weld your cap onto it so that you stop people from gaining access to the borehole. Or you do permanent decommissioning, where you backfill and you grout and you permanently cap your borehole so that nobody can ever use it again. Yes, I just want to show you quickly my own sort of procedure that we've developed. I'm just going to share this photo with you. Okay, can everybody see this groundwater resource development process?
Yes.
Okay, great. So I'm just going to run through this quickly. So the process, you get awarded your project, you do your desktop review and data analysis, followed by the hydrocensus investigation to see how many users are around the site. That helps you determine, is groundwater development feasible? Is it worth spending money developing this groundwater at the site? Yeah, if you've got low potential, then no, it's not worth it. Yeah, that's what you need to determine there. If it's not, then you review your alternative water sources and develop an efficiency plan to meet the site water demand. Because sometimes, if you're lucky, you know, someone would be running an inefficient system, so you can recover that water demand that they were looking to get with the borehole. But then if it is feasible, then can you do geophysics? Yes, you go. If it is feasible, then you go do your geophysical investigation. Sorry, that yes and no is switched around. So no, you go do it according to your desktop review and hydrocensus. And if it is feasible, you go do a geophysical investigation. You do installation supervision, design your borehole construction, and then you do borehole development. Borehole development is just where they do the airlift and they clear the borehole of any debris. Was your borehole successful? No, it wasn't. So then you go back and you review alternative water sources. Yes, it was. Aquifer testing, sustainable yield determination, and then pump equipment selection. You use that to develop your groundwater management plan and your reserve determination, which is something I think we'll go through in the next one, because that's something a lot of people don't fully understand, and I don't think it was really taught too much. Yes, how to do the reserve determination and what it actually means in the whole resource development process. And all of this information goes into your technical report, which is submitted to the client or to Water Affairs. And we go from there. We'll go back to the presentation. Now we're almost done with the presentation. I'm just going to go through these last ones quickly. Yeah, so some of the questions on a water supply project that we need to ask ourselves, besides the requirements of a water use license or a general authorization: is groundwater feasible? Can geophysics be completed at the site? How long is the site going to be operational for? This is quite important for your sustainable yield. You know, is the borehole going to be just for the construction phase, which is 1 or 2 years? Is it a permanent borehole? Is it going to be 50 years, 25 years? You know, how sustainable do you need to make this thing? Or not how sustainable, but how long is it going to be used for? And how many factors do you need to take into consideration? Do you need to take into consideration 10 years climate change cycles? All those kind of questions. Is there an alternative supplier available? That includes your municipal water, because some sites the municipality doesn't even supply you know, water to. There's no pipes going out there, so it's not even an option. And then one of the most important ones is, are there any existing groundwater users near to the site that may be impacted on by your abstraction at the site? Are you going to dewater your neighbor? Are you going to contaminate your neighbor? You know, all those things you have to consider, because at the end of the day, if he was there first, he's sort of got the right of way. Okay, then just quickly to go through your mining and large construction projects. Yeah, as a hydrogeologist, you can either be involved in a compliance perspective or an operational perspective, or even a combination of both sometimes. Depending on your life cycle phase of the project and also where the project is and who the client is. So in your greenfields projects, you typically do an operational type assessment for your feasibility studies or compliance type of assessment for EIAs, water use license applications, those kind of things, dewatering program designs, etc., just to make sure the mine or the construction goes smoothly. During operational phase, it's typically maintaining your EIA, your compliance, your EMPs, environmental management plans. And then also in some cases, mining starts dry and then they hit an aquifer that they didn't plan for or something, and you have to get involved in the operational side just to design the dewatering program. Like this picture here, the mine started off mining dry for about 5 years. And then one day they just hit this zone of water and yeah, it flooded. So we had to design the dewatering system there. And in closure and post-closure, it's usually in South Africa, your backfilling of the pits, your acid mine drainage management plans, water liability assessments for your closure licenses nowadays. All of those kind of things where the groundwater would be quite important. The important questions you got to ask during this scope of work is, where is the site located? That'll give you a good idea. Is it in a big mining area? Is it in a busy construction area? What's going on around the site? What phase is the project in the project life cycle? Are there any legislative or regulatory requirements for the investigation? A client won't always tell you what this is feeding into, but if they just say environmental authorizations, that is usually inclusive of an EIA and a water use license. So just be aware of that. In mining projects, has a mining method been selected? The difference in groundwater impacts from an underground and an open cast mine are quite stark. And what is the commodity being mined? Coal, you have to consider your acid mine drainage, coal and gold. Whereas, with the more inert product such as a sand mine or something, geochemistry doesn't really add value to the overall environmental process at the site. What's the lifespan of the project? Is it a 5-year construction project? Is it a 6 months construction project? Is it a 100-year life of mine? These things impact what you can and can't do. What is available for the site? And does the project require specific groundwater support? Is there a groundwater problem at the site that you have to solve? Do they need water supply? Do they need dewatering of underground workings or open cast workings? Is there a specific solution that they're looking for? Or is it just a general project? Are geochemistry results available for the site? That'll save you quite a lot of time, because your geochemistry is quite expensive and it takes quite a long time to run most of the tests, starting from 4 weeks up to 25 weeks, depending on what you want. And samples, the analysis goes anywhere from 5,000 to 50,000 Rand a sample. And then finally, what is the time frame for the study? Does the client want it tomorrow? Because then you can only write your name on a piece of paper, basically. Or is it an open thing where he just wants to answer? Or, all of these play a role in what scope of work you can design and what you can get away with doing. And so that is the presentation. So is there any questions on what we've gone through today, or anything you want more detail on?
No, I think that is a very good introduction. Yeah.
Okay, great. Thanks, Liesel. I appreciate the feedback.
Maybe on a
Thanks.
practical note, sorry, okay. I just,
Go ahead.
in my experience, what I would like to maybe have addressed is just to get back to the data collection part. Where are the good sources to collect your data in terms of, you know, borehole data, your weather data, and even legislation? Is that something that we can maybe discuss?
Yeah, I mean, uh, the best sort of places to get the data, Johan, is your NGA, the National Groundwater Archive. They've got a lot of really good data. You know, your borehole depths, water strikes, water levels, etc. At the moment, you know, their website is down. So you have to sort of email them, and then they get back to you. I mean, they got back to me on a Saturday. So they are pretty good. And then you've got the WR 2012 is also a good open source data set. You know, they've got your aquifers, your aquifer types, borehole potentials, all of those kind of things. What I'd like to do next week actually is go, and Johan, you must tell me if this is going to help. I want to show what the NGA will send you in terms of water strike, and then how to interpret this to get something useful out of it. You know, do your histograms, do the distribution graphs, all of that kind of stuff. Would that be helpful for you?
Yeah, my experience from NGA is that the data is outdated. I mean, there are records. I mean, the latest records would be many years old. So I don't know how often or how frequently it's updated, but I mean, it's still useful data. The other one that I'm aware of is the GRIP database, but that's in not all of the provinces. I know Limpopo and I think KwaZulu-Natal, but I might be mistaken. Have you made use of the chart website? Because I could never get that thing to run on my PC.
I was about to say, like, chart, it's a very nice concept, and the adverts for it look great, but I've never come right. I don't know if it's an IQ problem for me, but you know, I've never cracked that code.
Glad to hear that.
No, I'm also happy to hear that someone else struggled. You know? But look, Johan, I agree with you. The NGA is outdated, and the water level data I take with a pinch of salt. But the water strikes and the borehole depths, you know, that sort of it's usually representative. And
Yes.
an important thing that you can get from the NGA to help you determine how useful the data is your GPS accuracy. Yeah, then you can sort of see if it's a 10,000 accuracy, then I usually throw the data point away. You know, but if it's less than that, then it's usually okay. And yeah, it does get updated. There are probably about 5,000 to 10,000 points in the NGA database that they update regularly, like every 3 to 6 months. But the rest, they rely on consultants to release their data sets, which we don't do because the clients don't want us to. You know, a lot of clients want to hold their data to themselves, and it's tough because one mine doesn't want to let the other mine know what's happening on their site, and they don't want to see how much impact they might be having for whatever reason they have. Yeah.
Yes. Maybe on that point, rainfall data.
Rainfall data. On the Department of Water Affairs, they have the hydrology section where you've got your. And
I once tried to get some data from, I think, the South African Weather Service, and I got shocked by the quotes they gave me. So,
yeah, I mean,
so
I got
I'm
a quote for. Yeah, I think it's like 70,000 Rand for 20 years worth of data or something ridiculous.
Sure.
I've got a database. I'll try to find. I downloaded it about 2 years ago, and it is a grid of the entire world, and it's got sort of monthly precipitation values.
Sure.
But what I do there is I load that in, and then I do like a point grid for my site, and I assign January, February, etc. for every month. I assign that, and I get an average for the site area, which I correlate with old reports or the Meteo Blue or weather information websites.
Okay.
So if I find all that, I'll share it with everyone. I'll share these data sources and that kind of thing. And then also the open source data sets that I've accumulated, I can upload somewhere and share with everyone,
Oh, that'd be great, thanks.
Yeah, great. And then I see Radzani, sorry, Jan, is that it?
That's it, thank you.
Great. Radzani, you've got a question there.
Yes, thank you. What I wanted to ask is, it's not really technical, but I've heard one friend of mine asking me if I can compile a geohydrology report. So what I wanted to ask is, to what extent can really, because my experience is more in geology than hydrogeology, although I did a course or modules in hydrogeology. So to what extent can a geologist compile these reports, and at what point can anybody really be able to sign a hydrogeology study, for example, for mining permit application or mining rights? When they apply, they need this studies, and there needs to be someone who signed them. I don't know if you did get the question.
No, I sort of understand where you're going. It's a difficult question to answer in a straightforward way. It's sort of like how long is a piece of string? Because you've got the scientific knowledge of the geology, and you've got a working knowledge of the hydrogeology system and those kind of things. But in terms of like a mining permit, you need to have the ability to say, this is the source pathway and receptor, this is the impact that's potentially going to come from a mining environment, this is how it's going to travel through the groundwater system. So you're sort of feeding into an impact framework that you might not fully understand, because of that you don't have that groundwater specialist background, if that makes sense.
Yes.
So at the end of the day, to give you a completely honest answer, it just depends on the liability that comes with the project. Because a geologist, I know a lot of geologists that do groundwater resource projects, because they understand the geology, they understand the area. But when it comes to like a mining project or a project where you have to do a lot of interpretation, it might be quite challenging, and it might be a bit dangerous to sign off on the report.
Right. I get it. I understand.
Yeah. You see where I'm very hesitant to give a black or white answer. It's a very gray area,
Yes.
Okay.
Maybe
No,
I can just add to that point, Matthew.
Yeah, please, Jan.
Just from my experience, when I did my studies, I studied in 2008, but I re-registered at Northwest University. Sorry for the dog barking in the background, but I re-registered in 2012 and finished my master's in 2016, and my degree certificate says it's in geohydrology and hydrology, but we never, I think we did one module in hydrology. So technically, I'm qualified to do hydrological studies, flood assessments and so on, but I'm not experienced in that. So I'm not going to give myself out as a specialist and try and take that on. I would rather, leave that for the specialists. But I agree with Matthew, with your geology background, there's no problem for you siting a borehole, drilling a borehole, and just giving water where there's a need for water. But if it comes down to a mine needing sustainable water supply, and you need to sign off report on the sustainability, and there's a problem down the line, 2-3 years down the line, and they come back to you, then it's a problem. So then I would say get in the specialists and do a proper job.
That's the thing, and also, unfortunately, Radzani, when it gets to a point where there's an issue, that is where the sign-off becomes a bit of an issue for contention. If this is part of a permit application and the permit gets rejected or it goes out on appeal, that is unfortunately a weak spot where someone that's appealing against your mining client can say yes, but they're not a qualified person, or they don't have experience, or and then your client is going to come against you with your PI insurance, and it just becomes, people are not always forgiving. So yeah.
I understand. I totally understand.
Okay. Now I just want to get to a question that was posted in the chat here by Kondisi, and I see Neil's also answered it. The question is just, is there a need to conduct 2 or more geophysical methods to correlate the results, or is one geophysical method enough to produce accurate data? And Neil, you are correct that it's usually good to combine your magnetic and your EM, especially when you're in your Karoo formations, which is most of South Africa, if we're honest. You've got your Vryheid shales or your Eka groups, with a little bit of dolerite. If you've got dolerite dikes or diabase or something, then it's nice to pick it up with the EM and the mag. But if you've got, usually you use EM and mag, but sometimes you just use the EM by itself because there's no magnetic sort of intrusions or lithology units. If you're not going to pick up anything on the magnetics, then you don't need to use it. Same with the EM. If your weather depth is deeper than 30 or 40 meters, the EM method can't penetrate that deep. So then you would go straight to one method, which would be your resistivity. Gravity as well. In a dolomitic area, you might need gravity to pick up your cavities. So in the next one, when we talk about the geophysics, we'll go through it in a bit more detail. But your geophysics, remember, geophysical method only shows you the difference. It only shows you a higher magnetic unit versus a lower magnetic unit. It doesn't show you anything more than that. It'll show you a less conductive or a more conductive unit. It doesn't show you water. It doesn't show you anything, because you could have a weathered shale next to a competent shale and they would give you 2 totally different signatures. So your desktop review plays a big role, Kondisi, in determining which method you need to use and how many of them you need to use to get a confident answer. Okay. So Kondisi, I don't know, did that sort of expand on you? And Neil, do you agree with what was said there?
Yes, I believe it makes total sense what you said about the geophysical aspects.
No, great. Yeah, because Neil, what you said there is totally great, Kondisi. And you're totally correct in a Karoo setting and where you've got dikes and those kind of things. But like I've just come back from a site in Magaliesburg where it was all quartzites. And we only used the EM method just to try to pick up the weathered zone depth, which was about 12 meters. So we used the 40 meter and the 20 meter EM spacings. The magnetics wouldn't have been helpful there, and the resistivity was too expensive for the client. So you've got to take all of these into considerations. And then I think we'll just do one more question before we end for today. I see, Patrick, you've asked to give some insight into your hydrogeological proposals for tenders. I don't know if you can unmute yourself and just sort of expand on that, or if you can type it in there just so we can get a bit more of what what exactly you're looking for there. Yeah, we'll just wait for Patrick. But is there any other questions, on what we went through today and what we're sort of planning for the next couple of sessions? Okay, Patrick, I see there. You can't unmute there on your microphone, Patrick. Oh, there we go, Patrick. I think you can talk now. No. Okay. But yeah, anybody else with a question? No. Okay, so I'll try and expand on Patrick's thing quickly. In terms of a tender, you have to look at your scope of work that the tender lays out for you, because usually they'll do a copy-paste job, in my experience, and I'm sure in your experience as well. It'll talk about something that doesn't exist in the site area, or so you've got to sort of read the quotes, the documents quite carefully. And you've got to ask yourself the questions that we've gone through in the presentation. What do they need? How much confidence do they need in the answers? How long is this project going to take? Doesn't need to be completed in 6 weeks or 6 months or 3 years. All of those things would come into play. A tender at the end of the day is just as any other request for quotation. The only difference is that it usually has a lot more commercial and paperwork associated with it. But in terms of approaching it, it's, in my opinion, just like any other proposal. I hope that sort of helps you, Patrick. Okay, great.
Matthew, so just before you close, can you just perhaps share the link to your YouTube channel? You said you'll be uploading this on YouTube.
Yes, no, I'll do that. I just need to, I'll be honest with you, I need to figure it out. And then I will post it on LinkedIn and I'll send it to everybody in the group. I'll also just make sure that everything is clear, and I can put everything together if I have to edit it or whatever. Okay,
all right,
and then
thanks.
I'll also send the PDF version of this presentation to everyone, and I'll put it on my company website probably tomorrow or during the course of the weekend, and then we can all go through it. If there's any questions, you guys have all got my email. You can either send it to the Matthew at Alicanto address or the GW Mentor at Alicanto Water, just with any comments or what you would want to see more of, if you want more pictures, more detail on something, or anything that we can include with the next session, which would focus on the groundwater resource development. And from Johan's question, we're going to look at sort of the data, where we can get it, how to make it useful. And then Condisi, we'll look at the geophysical methods. And, you know, if there's any other aspects you can see in that on the slide that's on the screen now, you know, if there's anything else we want to look at there, we might split it into two, you know, we do Wednesday and Thursday or something. Yeah, we just keep an open line of communication between all of us, and then we can plan around it and make sure we meet the expectations. But okay, then I think, guys, we're done with the first session. I hope it met everyone's expectations, or at least sort of gave you a base platform of what I'm trying to get across here. And I hope you give feedback from your side to say what would improve it for you guys and make it more engaging or more informative. Yeah, I'm open to any suggestions.
Thank you.
Okay, thank you very much, guys. I appreciate it. And you must have a good weekend, and please stay warm. I think there's a massive front coming. And just keep an eye on the LinkedIn page, and I'll send you a mail. We'll confirm everything for next week.
All right, thank you.
Okay, thanks, guys.